Hello everyone, this is Siri Dubaka. I'm a researcher in the field of social robotics from Robotics Innovations Lab, IAC Bangalore. My other teammates are Mukil Sarvanan and we are working under the guidance of Professor Abrar Rai Chaudhary. It is a great thing that robots have come into our social space and helping our elderly to make their lives easy. But as we are deploying robots with the most vulnerable populations, we have to be very careful and make sure that robots carry some ethical and responsible behavior rather than just doing and working in a mechanized way. When robots interact with elderly people, ethical issues are bound to arise, which can greatly impact the trust and relation between human and robot and affect the quality of life of the elderly. So, we have carefully designed the decision making processes to solve the ethical issues that can arise in a elderly care scenario and parallelly balance all the ethical dilemmas. Design proposal. According to the user needs and robots capabilities, we have given the following set of tasks for the robots to perform. And we majorly divided the task into fetching and non-fetching task. Fetching task can be divided into command-based, timeline-based, and need detection fetch. Command-based fetch happens when the person commands a robot to fetch anything. In timeline-based fetch, irrespective of the person commands or not, the robot fetches an item based on the predefined timeline like diet or medication timeline. In need detection fetch, if a robot detects any need of an object or if a person is in emergency, the robot fetches the necessity object to the person. So by keeping robots high perception and communication in mind, we have even considered non-fetching task in which the robot can help the person with daily activities like eating, washroom, dressing, and waking up, and even checking the person on regular intervals, keeping track of the person, and some informing nurse and some predefined task if emergency detected, and helping if detected to be depressed and helping them socialize. So all these kind of tasks which come under non-fetching tasks. Ethical issue identification. After doing some critical research and literature review on robots deploying into elderly care scenario, we have identified some major ethical concerns. Out of them, number one is safety risk. What if robot can fetch an unaccessed or harmful object to a resident? According to the literature review done on care-centered value-sensitive design, safety is of paramount interest in caregiving. And the next important concern is if the robot denies to fetches an object to a person, there is definitely a chance that the person can feel loss of autonomy. And the next comes privacy concerns. What if robot fetches a person's personal or financial item to others? It's important that the robot knows the boundary. What if two commands happen at the same time? Which one should the robot fetch? And what if two persons fetches same item at a time? Whom should the robot select? So this is the decision dilemma. Everyone in the elderly care home are different with different health conditions, different personalities and choices. So should the robot consider each and everyone's personality and behave, or should the robot behave same with everyone? What if users can't estimate the system and gets confused with the robot's action? According to a literature review done, emotional expression in AI bots can be permissible as long as it is transparent and not manipulative. So it is important that the robot openly communicates and be transparent for the user to create a trust. What if robot becomes the cause for infection in the elderly care home? And the other most important concern is what if anyone can easily change the guidelines or timelines of residents in the robot, which can lead to serious consequences? Elderly care home are surrounded by persons' safety, autonomy, privacy, transparency, personalization, situational awareness, empathetic behavior, and hygiene. And which we made sure that we have integrated all these ethical principles into our design solution. To resolve the above ethical issues identified, when a robot is perform the mentioned task, it is important to integrate the system with the critical ethical issues we have discussed. To make robot take ethical decisions in challenging situations, it would be easy if we give it some classifications of objects, things, people, situation, and location, using which it can perform the evaluation and take the decision. Based on items present, usage, and preferences of people associated with the elderly home, we have given two modes of the robot, which will activate based on the items given on it. Number one, general mode. Number two, personalized mode. General mode gets activated when the fetched objects are general or commonly used by everyone in the home. Personalized mode will get activated when items to be fetched are personalized to everyone in the home. You can see objects which comes under general mode are hazardous, restricted, shared items, general edible and hygienic sensitive. And objects which comes under personalized mode are use or defined edible, medical, personal and user restricted.
Classifying the types of users, destinations, and situations are of prime importance to understand the system better and to make informed decisions. Here we classify users based on the roles that they do in the elderly care homes, such as residents, visitors, security, and medical staff. Locations that are hygiene sensitive, such as washrooms, toilet, and laundry rooms, are classified from the rest of the regions. And situations are classified as emergency and normal circumstances. Taking into consideration of stated ethical principles, we put forth rules to solve the ethical issues. Fetching rules are broadly categorized for two modes, namely generalized mode and personalized mode. Whenever a general object is asked to fetch, the general mode gets triggered. If a hazardous object is fetched, no one gets the access to the object except the security staff in the normal circumstances. But in case of an emergency, the resident gain access to the object. Likewise, food items are only delivered to hygienic destination such as living room, dining room and bedroom, but not to the washrooms and toilet, satisfying the hygiene condition. Similarly, when an object like medicine, credit card that are owned by a specific user are asked to fetch, the personalized mode get triggered and a special permission is mandatory if a diabetic person is demanding sweets that are restricted to the person. In this case, a nurse is notified and the request is only approved after considering the essential factors like the person's health and frequency of fetching. Our proposed method is also capable of making acute decisions during critical non-fetch tasks. The robot is designed in a way that it requires concern of the resident before entering the room, prioritizing person's autonomy. The design also emphasizes on situational awareness, hygiene, security of financial information, trust and transparency. To implement the proposed solution, we require a collection of sensors that bring in the essential information. To become aware of the external situations, we require speech recognition, object recognition, facial expression, and gesture recognition. The biggest strength of the ethical robot design is that it addresses major ethical issues, including safety, autonomy, privacy, trust, and empathy. Besides being personalized, it makes decisions based on the situation. The few of the limitations can be accurate behavior recognition and maintaining a trade off between strict decisions and autonomy. Thank you.